In this Trig Survival Guide video, we are going to verify a trig identity. So we'll get secant x plus cosecant x multiplied by sin x plus cosine x should equal 2 plus secant x cosecant x. All right, so that's quite a lot to deal with. Let's go on, and we'll first start by strategizing and deciding which side to work on. So let's first look at which side to work on. Usually we like to choose the more complex side as it'll offer us more options. It's usually easier to simplify or manipulate more down to less than to rebuild less into more. So in this case, I think the left-hand side will be a great candidate to work on. Remember, we can only manipulate one side. So let's go ahead and draw a vertical bar through the equal sign. That'll just help us resist that temptation to manipulate the right-hand side at all. In terms of our strategizing, I think that we're offered two binomials being multiplied together. So a natural first step would be to go ahead and multiply these through to see what we're working with. We also may want to go ahead and rewrite the secant and the cosecant in terms of their reciprocal identities. So let's go ahead and multiply, and then we will rewrite in terms of sine and cosine. All right, so we'll FOIL this binomial. So we're multiplying the first terms first. We'll have secant x, sine x, and then we'll multiply the outer terms. We'll have plus secant x, cosine x. Then the inner two terms, plus cosecant x, sine x. And the last two terms, plus cosecant x times cosine x. All that equals, I'll abbreviate it right side instead of rewriting the terms above. All right, so now we're looking for our next step. We sort of pause to assess. I do think that rewriting things in terms of sine and cosine could be great. As we were multiplying terms, I noticed that we ended up with two reciprocals being multiplied. So secant and cosine are reciprocals, as are cosecant and sine. And so you could rewrite those in terms of sine and cosine, but we know that secant is 1 over cosine, so when we multiply two reciprocals, we should get 1, and that'll be similar for cosecant and sine. You could rewrite cosecant as 1 over sine if you wanted, or you could simply know when you multiply something by its reciprocal, you end up with 1. All right, so let's see what we have here. We'll rewrite secant in this first term as 1 over cosine x times sine x. And that's, of course, over 1. These are connected by multiplication. We said when you multiply these two reciprocals, you get 1. Feel free to show that out with the reciprocal substitution if needed. And then with the third term, we also multiply two reciprocals, so we get 1. I'm feeling confident right now about that 2 on the right-hand side, just taking a second to pause and look over there. So the other two terms, the first and last, will hopefully be able to simplify to secant x, cosecant x. All right, so that last term, let's rewrite it in terms of sine and cosine. We have 1 over sine x times cosine x. And that all equals the right-hand side. Taking a moment to pause and assess, like we talked about, we feel confident that these two terms, they combine to be 2. So that's the first part of the right-hand side. So we really should be looking at these two terms and grouping those together. They're connected by addition. How can we work those two terms to equal secant x, cosecant x? That's our main goal for the rest of the problem. So in order to combine two terms into one, we have fractions. It looks like a common denominator would be a really helpful strategy here. So we'll multiply that first term by sine over sine. Okay, that's like multiplying by 1. We'll multiply that last term by cosine over cosine. And that way we get a common denominator of sine cosine. So in the next line, we'll simplify, we'll add those two ones together, and we'll also group the terms that we want to be together. So from these two ones, we have a 2. And then let's rewrite, we have plus the numerator from the first term, 2 sines, so that becomes sine squared over sine cosine. Then the second term, or it was the last term, we have 2 cosine x's in the numerator, so that's cosine squared all over our common denominator, sine cosine. And so we can combine those two together in our next step because we really want these two terms to condense down to one. Like we said before, we're looking to simplify it to secant x, cosecant x. At this point, you may be noticing that the numerator, when we combine these two terms together, is actually part of a Pythagorean identity. We know that sine squared plus cosine squared is 1. So when we rewrite these together, let's go ahead and make that substitution. So we still have the 2. We have plus, replacing the whole numerator with a 1 through that Pythagorean identity. And that's all over sine x, cosine x. And at this point, you could split this term, connect it by multiplication. We have 1 over sine and 1 over cosine. And using reciprocal identities, we know that 1 over sine is cosecant, 1 over cosine is secant. And so we are basically there. Finish that out equals the right side just to make it nice and neat. And we'll write this as 2 plus the 1 over cosine is secant. The 1 over sine is cosecant. And that equals the right-hand side. We'll write it all the way out. We've got it. We've proved this trig identity. If you're looking for more examples of verifying trig identities, I'll post a link in the video description, so be sure to check that out. And thanks for watching.